is the video lesson for 8.6c in the Pythagorean Theorem unit. Our objective today is to use models and diagrams to explain the Pythagorean theorem. So we're not actually going to be really calculating much today. We're just going to be using these models, pictures and things to explain the Pythagorean theorem. Now, what is the Pythagorean theorem? The Pythagorean theorem is named after a guy named Pythagoras, and he came up with this idea that in a right triangle, any right triangle, there's a relationship between the lengths of the sides. Now this only applies to right triangles, the ones that have a 90-degree angle. And the relationship between the sides, if I call this side A, and if I call this side B, and we call this, let's see, side C, then there's a formula that we can use to figure out any side that we might be missing. Let's zoom in here. These are going to be your notes for today. There's not a whole lot that you need to write down. So here's the formula. A squared, so the length of this side squared, or times itself, plus B squared equals C squared. Now there's something very important that you need to realize here, and that is the length of this side right here is not A squared. This is just A. So let's say that the length of this side is 5. The formula would have 25. If the length of this side is 10, then B squared would be 100. So you have to realize that these are not the same number. This is just the length, and this is the length squared. Now, we could also have labeled this A right here and B right here. But C is the hypotenuse. Okay, hypotenuse, that's an interesting word. And my hypotenuse is the longest side it's also going to be opposite the right angle, and it always has to be C. Okay, so A and B are interchangeable, but C has to always be the hypotenuse. And it's opposite the right angle. That means it's across from it. It's not actually touching it. A and B form the right angle. Now, the way that we came up with this theorem, or Pythagoras came up with this theorem, is by actually creating squares. So we're going to look down here at number 6 and do number 6 together, because you see that they have made squares here. So we're going to take this problem a little bit further than it needs to be taken. So let's use our same colors down here. We're going to call this A. And we'll call this B. And the hypotenuse, the longest side, is C. It's kind of an ugly C. So, A equals what? Well, it's 3 units long, so A is 3. Notice that if I make a square that's 3 by 3, then I get 9. So the square that it's making here is A squared. So that's A squared. If we look at B, B is 4 because it's 1, 2, 3, 4 units long. If I make a 4 by 4 square, So 4 squared, or b squared, is 16. And the same thing works for c. c is 5 units long, and 5 squared, or c squared, is 25. So the way that we would actually solve this, if we were going to use the Pythagorean theorem, just a second here. Okay, if I was going to use the Pythagorean theorem to actually solve this problem, then I could say, let's start with my formula, a squared plus b squared equals c squared. And then because we always start with our formula, remember, and then we always plug in what we know. So then I'm going to plug in a is 3, so that would be 3 squared, plus b was 4, so 4 squared, 4 squared, okay, and then that would need to be equal to, this was 5, so 5 squared. And then we can do these in our head, or we can just put them in the calculator. 3 squared is 9. Oops, sorry. 4 squared is 16. And 5 squared is 25. And 9 plus 16 is 25. So that means that this works. Now normally, you wouldn't be given all of the numbers. Normally you would be solving for something. Either we're given A and B and we need to find C, or maybe we're given A and C and we're looking for B. It doesn't matter. We're always going to use the same formula. And remember that C is always the hypotenuse or the longest side. So to answer this question here, the model demonstrates which formula. It is the Pythagorean theorem. A squared plus b squared equals c squared. And I'm going to actually write out here Pythagorean theorem. Just to remind myself what that is. So, your job today, you're going to need 5 stamps by the end of today. So I'm going to go ahead, please go ahead and write in 5 right here. And we'll fill in the rest of this in a little bit. Please write today's date here where it says due. And put your first and last name before we move on anywhere else. And you're still going to fold in half and glue on the side, but this is just for grading purposes. Now I want to go over this really quickly. You already know all of this, but remember to turn in your paper on the due date, so you will need to turn in your paper when I collect them, because late papers lose 10 points per day just right off the bat. So turn it in even if you're not quite finished, because you can still correct it. But it'll be better to have a grade in the grade book than a 0. You may correct your paper up to 100% until the end of this unit. So as long as we are in the Pythagorean theorem unit, if you get your paper back and you made a 90, you can correct it up to 100. After that, after the test, you can correct it up to a 70. Remember, do not erase your original work and your answers. That's something we've been having a little bit of an issue with. I want to be able to see what you did originally. And then, of course, once your paper's graded and you don't need to correct it anymore, then you fold it in half and glue it into your journal. Okay, so today, the ones that I'm grading you on, the ones you're doing on your own, are 7, 3, 8, 9, and 11. So those are the ones that you're going to need stamps on. Right now, I'd like you to come back over here and just look at number 7. And you're going to be looking just at what happens in the picture. So we're looking at the triangle and you're looking at what happens to give us the numbers. So I'm going to pause the video, or actually I'd like for you to pause the video. You're going to do number 7, bring it to me for a stamp, and then we'll continue with the video on number 2. Number 2, a business owner gives a landscape architect the sketch below. A landscape architect is just somebody who designs buildings and things on the land. They're going to do the landscaping outside. Without doing any mathematical computation, the landscape architect tells the business owner that the drawing is incorrect. How does he know? So we're not doing any math here, we're just talking about how we know that this is incorrect. So let's look at what they're wanting to do. It looks like this is an outdoor horse riding area. And the horse riding area itself is right here. Looks like maybe this will be a stable or something in a water trough. And this dotted line here, we're told, is a fence. So we're proposing that that a fence be installed between these two areas. So without doing any mathematical computation, which means we're not going to solve anything, we're just going to look at it and find what's wrong. So I'd like for you to look at this for a second and try to figure out what's wrong, and in just a minute we'll go over it. Okay, hopefully everybody was able to figure out from our notes that we took up at the top here that the hypotenuse, the one that's across from the right angle, always has to be the longest side. Well, right here, this is our right angle, which means that this is the hypotenuse. And we see that it is not the longest side. 52 yards is longer than 50 yards. So, actually, looks like they called that 50 feet, actually, but surely they meant yards. So, I would say the hypotenuse is not the longest side in the drawing. Which means that this is not a right angle, or not a right triangle. So this is not a right triangle. Okay, so remember, if you ever have a triangle given to you and they're telling you that there's a right angle over here and the opposite side is not the longest, then you know automatically, even though they're telling you it's a right angle, it can't be. So that would be what's wrong with it. So now I'd like for you to look at number 3 and number 8. Number 3 and number 8. You're going to work both of those problems on your own, and then bring your paper to me to get your stamps on those questions, and then continue with the video. On number 1, it says, in one of the triangles below, the formula a squared plus b squared equals c squared can be used to find the length of the missing side. Which triangle is it? So, remember that this can only be used for right triangles. Only right triangles. And the only right triangle that we have here is B. So we could say this is A, this is B, and this is C, and we could use it to find the hypotenuse here. So it can only be used on right triangles. Let's jump over here to number 4 before you do number 9 on your own. Let's zoom out a little bit here. Let me get that bit of light out of here. Okay, let's see. Use the Pythagorean theorem to find the figure that is a right triangle. So, we're not actually solving the Pythagorean theorem right now. You're not going to do that at all today. So we're not looking for any missing sides. We're just going to be plugging these numbers into our formula to see which set of numbers actually works. So, let's look at f. Remember, the formula is always a squared plus b squared equals c squared. And we always start by writing down our formula, and then we plug in what we know. So I'm going to find my longest side. It says 81 is the longest, so that has to be C. A and B don't matter so much, so I'm going to use 21 for A. So I'll say 21 squared plus 72 squared equals 81 squared. So all we did here is plug in our numbers, and we had to make sure that C is the longest side. So basically, maybe this is a right angle, maybe it's not. We're testing that. So now we just plug these numbers into our calculator. 21 squared, or 21 times 21, is 441. 72 squared is 5,184. And 81 squared is 6,561. So now we need to check and see, okay, is 441 plus 5,184? Nope, that is not equal. This is 5,625, which is not equal to 6,561. So F is not a right triangle. Let's look over at G. Okay, so again we start with the same formula. A squared plus B squared equals C squared. And my longest side, and again, don't go based on what it looks like. If they told us that, that this was the longest side, then we would have to go based on the numbers, not what it looks like always. So C is going to be 26. So we'll use 24 for A, 24 squared, plus 12 squared equals 26 squared. So go ahead and plug these into your calculator as I do it on my paper, just to get the practice and see what the process is. So 24 squared is 576, 12 squared is 144, 26 squared is 676. So we're going to test it now. 576 plus 144 is 720, which is not equal to 676. So it's not G. Now be careful here, because this looks like a right triangle, doesn't it? It looks like this would be a right angle here, but of course it's not. We have to go based on the numbers. So those numbers cannot give us a right triangle. Looking at H, let's do the same thing. So as I write it on my paper, I want you to go through the process on your own and just be checking. So I'm going to be quiet now and let you work simultaneously. Okay, so hopefully you got something similar to what I got. Again, if you switched up the A and B, that's fine, as long as 29 was your C. And I got 841 on both sides, which means that this formula works. Oops, I do not know what this is. Okay. This formula works, so H is a right triangle, even though it doesn't really look like it. And if we had to find the right angle, it would have to be across or opposite from the hypotenuse, so that would be our right angle. So we're going to go through J just to double check. We can probably do this pretty quickly now. I'll let you work as I work. Always starting with the formula and then filling in what we know. And I got 34 equals 36, which is not true, so that is not a right triangle. So to do this question, all we did was take each triangle, figure out which side had to be C, plug the numbers into the Pythagorean theorem, and use our calculator to help us solve. The one that gave us the same answer on both sides, in other words, the one that actually worked in the formula, is the right triangle. I'd like for you now to look at number 9. You're only doing number 9. It's very similar, it's just in word problem form. So you're testing to see whether these numbers form a right triangle. When you're finished with number 9, please bring it to me for a stamp, and then we will continue with the video. I wanted to do number 12 with you because this one is sort of solving the Pythagorean theorem, so I'm just going to walk you through it. This is what we're going to do tomorrow, so you'll have kind of a head start. So it says in the diagram below, RSTU is a rectangle. Okay, that's RSTU, so this right here is a rectangle. And the two shaded regions are squares. So this is a square and this is a square. If the length of SR is 4, let's plug that in. SR is 4. And the length of ST is 8 meters. ST is 8 meters. What is the length of PQ in meters? PQ. Let's look. PQ is the hypotenuse. This is what we're looking for. We're solving for C because it's across from the right angle. So this looks pretty complicated, but really it's just a process of moving some numbers around. So we know, let me find a different color here. We know that this length right here is 4 meters. Which means that this length is also 4 meters. And since it's a square, this is 4 meters. So I'm going to call this 4. Now let's go back over that because some of you may be wondering where we got that 4 from. So we were told that this is 4. That means that the other side of the rectangle right here is 4. And we were told up here in the problem that these are squares. So if this side is 4, so is this side. And now we can do the same thing for the other side of the triangle. If we know that this is 8 meters, then we also know that this is 8 meters. And since it's a square, this side is 8 meters as well. Again, this is 8 meters because the problem told us so, which means its opposite side also has to be 8. And if this is a square, then all 4 sides are 8. So now we're stuck with a problem that's a lot simpler. I have a right triangle that's 4 and 8, and then C is what we're solving for. And there's my right angle. And that's all we're doing. So now we just need to solve that. So let's start with our formula. A squared plus B squared equals C squared. A squared plus B squared equals C squared. Then we plug in what we know. So let's use 4 for A, 4 squared, plus 8 for B, so 8 squared, equals C squared. Now I want to pause for just a second here. Whenever you're asked the question, well, what are we going to plug in for A? Don't say 4 squared. Okay, that's very important because A is 4. We're not plugging in 4 squared. We're plugging in 4, and then squared is part of the formula. Same thing for B. When I say, what are we going to plug in for B? The answer is 8, not 8 squared. We plug in 8 in place of B, and then the squared is still part of the formula. So just keep that in mind. If I ever say, no, that's not right, then it's because I need you to think about it as just the length of the side, and then we square it because of the formula. Okay, so continuing here, we get 16. We may have these memorized. 16 plus 64 equals C squared. And we're just solving this like any equation, any formula. 16 plus 64, if we plug that into our calculator, we're going to get 80. So 80 is equal to C squared. Okay, now I'm stuck. Because now I don't have C by itself, but I don't know what to do instead. So just like in any formula, any equation, if we are multiplying, then we're going to do the opposite and divide to get the variable by itself. If we're subtracting, then we're going to do the opposite and add to get the variable by itself. So in this case, we're going to still do the opposite. The opposite of squaring a number is to take the square root. The opposite of squaring a number is to take the square root. So I have to take the square root of both sides. So the square root of 80 equals, okay, C squared. If I take the square root of that, the square root sign and the squared sign cancel out, so I'm left with just C. Let me go over that again. We did the opposite of squaring a number, which is to take the square root of both sides. And then just like plus 8 minus 8 cancel out, or just like 2x divided by 2, those cancel out. C squared, and then taking the square root, those cancel out, and I'm left with just C. Now we could figure out the square root of 80, but we don't have to, because the problem, or I'm sorry, the answers are left in square root form. So C is equal to the square root of 80 meters. And if we put that in our calculator, just to kind of get an idea of what that would be, the square root of 80 is about 8.9 meters. So that is the longest side, which means that the answer is reasonable. So we'll do a lot more with this tomorrow when we're solving. So now I'd like for you to do number 11 on your own. All you're doing is drawing a picture. You're not solving anything. Draw the picture, label it, make sure that I can tell what's what, and then bring it to me for your stamp, and then you'll be able to turn in your paper for today.